Hi Chem Peeps. Today we're going to start final exam review, and I'll have several videos based on the topic. Today we're going to talk about moles. And as a teacher of 31 years, when you're doing a final exam of all the material that you have taught for the year and having a limited time for the students to complete it, you really have to be selective. And so in the questions that I have here on the right of the screen, questions 44 through 51, these are actual questions from a final exam that I used towards the end of my career. And it allowed me to assess different skills that my students either learned or didn't learn. So what we're going to do is go through these questions, and I will explain things as we go. So question 44 says, 1 mole of any element will have. Well, this question is being asked because I'm asking the students, do they understand what a mole is? And so here is my mole map that I used in class. And when we look at this mole map, in the center we have moles. And the relationship of moles is that there's a mass that's equated to the substance. And we get the mass from the periodic table. Okay, and with moles there's a number of particles, and those particles can be atoms or ions or molecule units or formula units, but it doesn't matter. It's always Avogadro's number, 6.02 times 10 to the 23rd. So looking at my selection that I have here for my question, let's see which applies most to what we've talked about here. I'm trying to get this to minimize for me. There we go. So if we look at the question, yes, there are 6.02 times 10 to the 23rd atoms. That should be superscripted there, that 23. 12 grams, no. If I look at the periodic table, the substance of 1 mole that has 12 grams is carbon. So B is not correct. C, the atomic weight off the periodic table. Yes, that is true. All substances, masses on the periodic table are equivalent to 1 mole. And so the answer to 44 is C. Okay, 45. There are the same number of atoms in 24.3 grams of magnesium and 32.1 grams of sulfur. A lot of my students miss this question. This goes back to my understanding of the periodic table and the mole. On the periodic table, magnesium has a molar mass, which I abbreviate MM, of 24.3 grams. That is equal to 1 mole. Now, sulfur has a molar mass of 32.1 gram, which is equivalent to 1 mole. Because it's 1 mole, they both have 6.02 times 10 to the 23rd, and in this case, atoms, because we're dealing with the element. And so the answer here is true. Okay, question 46. Let me get this off of here. 46 states, how many moles are in 150 grams of lead? So again, looking at my mole map, I have grams of substance. So I'm starting here in Grahamtown. I'm going to change the color. I'm starting here in Grahamtown, and they want to know moles. So I am going to go down this arrow, and it tells me to multiply my mass that's given to me by 1 mole over the molar mass. And of course, the molar mass is going to be found on the periodic table. So let's go ahead and solve this problem. Put this back up here. Make myself some room, making quite a mess. So I am starting in Grahamtown, and I have 150.0 grams of lead. Now, I did teach my students sig figs, and I could ask direct questions about sig figs, but I'm probably going to assess it in my calculations that they have to do here. If I look up lead on the periodic table, it weighs it has a molar mass of 207.2 grams for every 1 mole. Notice that the grams are on opposite sides. And when I multiply and divide here, I am going to get 0.6 7,239 moles. The reason I went that far out is that the beginning substance given to me has 4 sig figs. So I am looking for 4 sig figs in an answer, and that's where I'm going to assess my students. So the answer for 46 is going to be A. Now you can see here I didn't try to trick them, but I have seen, like in College Chem and AP questions, where they will give answers. The other choices will be variations, like 0.7 may be one of the answers, maybe 7 to 4 will be another, and that's a little trickier, but again, it's a higher level of chemistry, and that's where they might assess that. Okay, so let's go to question 47. 47 says the empirical and molecular formula of CO2 are the same. So this is having my students apply the definition of empirical formula, and empirical means the simplest ratio. And molecular formula is going to be the actual. Now, that's the definition, but do I understand what that means? Well, they can be both. Example of a substance that has both a molecular formula and empirical formula that is the same is water. Water is H2O. It is 2 to 1, hydrogen to oxygen. It cannot be simplified any further as whole ratios. Or it can be different. Different. No, it doesn't want to write. It's being fussy. Different. Example, hydrogen peroxide. Its actual formula is H2O2. That is a 2 to 2 ratio. But that can be simplified. I can simplify that by dividing the ratios by 2, and I now get a 1 to 1. So this is an example where the molecular formula is different than the empirical formula. So let's look at the example they give us. Carbon dioxide is CO2. That's a ratio of 1 to 2. That cannot be simplified any further. So it is both. And so the answer here is true again. Okay, next problem. The empirical formula is always the simplest whole number ratio of a compound. Well, we've already defined that. That's a pretty straightforward question. The answer is true. The 49 says the empirical formula of a substance is P2O5. The experimental molar mass is 283.89 grams per mole. Determine the molecular formula of the compound. Now, going back to the PowerPoint that I would give to my students, they would have to know how to determine an empirical formula and a molecular formula. So if we look here, I have the explanations for my notes, which you can do a screenshot here, that gives the steps of determining an empirical formula. And so when you're starting with percent comps, which we will do down in question 50, you assume 100 grams, and those percents are now equated to grams. You convert the grams to moles. Then you set up a mole ratio, dividing all values by the lowest in that mole ratio. Here's the tricky part. If I was doing a college chem class or an AP class, I would do something that's a little more difficult with my calculations. When I divide the ratios by the smallest in that ratio, if I have an answer that has a decimal of 0.2 or less, I can just drop it and just leave the number alone. If I have a value that has a decimal of 0.8, I now have to round that number up to a whole number. And then if the mole ratio does not consist of all whole numbers, then I have to multiply it. So example, if I had something that was 1.2 to, let's see here, what do I want? I'm doing this off the top of my head. A ratio that is 1.2 to 2.5. Well, first of all, this number can now be 1. And the 0.5 is neither 0.2 or 0.8. So now I need to multiply this ratio by a number that will make this whole. And in this case, it'll be a 2. So my new ratio, or my accepted ratio, is going to be 2 to 5. Okay, so this part in part 3 is a little trickier. Would I include something like that on my test? Maybe if it was a more advanced class. And so once I get those whole numbers, those become my empirical formula ratio. So let's look at an example that we're going to do. Did we answer the question? No, we didn't. So I have the empirical formula. It is P2O5. Now, I know that the molecular formula, which could be P2O5, has to weigh 283.89 grams. Okay, so what is this weigh? Well, 2 phosphoruses off the periodic table is 31.0, which comes out to 62, and 5 oxygens. Sometimes my pen gets ahead of the computer. So 5 times 16 grams off the periodic table is going to give me 80. That means the total mass of this empirical formula is 142. So they are definitely going to be different. So how do I figure out what the molecular formula is? Well, if we just look real quickly, I'll finish it here in a minute, but I want to just show this. You need to screenshot this. Once you know the empirical formula and you're given the mass of the molecular formula, you just divide them and see how much bigger or if they're the same. So let's look at this example. I know it needs to weigh 283. Come on, computer, catch up. Wow, someone is being fussy. 280. Wow, I'm really struggling today. I apologize. 283.89 divided by 142 is 2 times bigger. And so my P2O5 is going to be increased by double. So the final answer is P4O10, and the answer is C. Okay, let's go to the next question. Just clear the screen. Okay, it says, what is the empirical formula for a compound? So they gave us percents. If you remember when I showed you the notes, it tells you those percents. We assume 100 grams, so those percents are now grams. So we have 29.44 grams instead of percents of calcium. We have 23.55 grams of sulfur, and we have 47.01 grams of oxygen. We're going to convert these to moles, and so calcium on the periodic table for every 1 mole is 40 grams. Sulfur for every 1 mole on the periodic table is going to be 32.1 gram, and oxygen for every 1 mole on the periodic table, it is 16.0 grams. Now, I'm going to tell you again, with these type of problems, percent comps, it is really important that you keep your sig figs. So we're starting with 4 sig figs. So when I do these calculations, I want to have 4 sig figs over here. And if you don't do that when you're doing these kind of problems, you often come out with numbers that are not whole or close enough to hold to round. So if we look here, the first one is going to be 0.7360. The second one is going to be 0.7336. And the third one is going to be 2.938. And I kept 4 sig figs in all of those. So my ratio is 7360 is to 0.7336 is to 2.938. And according to the notes that I increased for you to screenshot, you divide all of these by the smallest in this ratio. And so the smallest in this ratio is going to be the 0.7336. And so when I divide that, the first one comes out to be 1.99, which can be rounded to 2 because that decimal is greater than 0.8. The second one is obviously, I apologize, it is Actually, not 1.99. I'm thinking of a different problem. It comes out to be 1. I apologize. The second one is 1, and the third one is 4. So what does that mean? Well, these are the subscripts in the formula. So Ca is a 1, so we don't put a 1 down. S is a 1, we do not put a 1 down, and oxygen is a 4. So this is the final answer here, and so coming up here, it is A. The last question that we're going to go over is 51. Let me clear my screen because I need some working space here. It says, wow, I got a lot going on here. Erasing answers as I go, sorry. Okay, it says, what is the percent composition of carbon in CONH2 taken twice? So I need to know what the total weight is here. So I have 1 carbon, 1 oxygen. I actually have 2 nitrogens, and I have 4 hydrogens. So carbon weighs 12.0 on the periodic table. Oxygen weighs 16.0 on the periodic table. Nitrogen weighs 14, so 2 of them is 28.0, and hydrogen weighs 1, so 4 of them is 40. So when I add this together, I'm going to get 60 grams per every mole as the weight of this. Well, I only need to know carbon. So what is the percent of carbon? Well, carbon in this compound takes up 12 grams of the 60. So I'm going to divide these times 100, and its percent composition is actually 20%. So our final answer is C. And so I hope this helps you review moles and some things that we do with moles. I will have more videos coming out for final exam review. I'll try to push them out pretty quickly this week and next week so that you have them for your final exam. I hope it helps. Leave me a like, share it, save it, and leave me a comment if it helps you or if you have more requests. And I will talk to you later.